All right, so in this section, we're going to continue to look at parabolas, but we're jumping ahead to chapter 10, where we're going to look at parabolas in a slightly different way. In ancient times, Archimedes knew about parabolas. Also, they were first created by a Greek named Apollonius, at least in the European world. And to look at this interesting question, define a parabola in terms of the focus and directrix. Well, actually, it's just the definition of a parabola. A parabola is a set of points that is equal distance from a point and a line. That point is called the focus, and the directrix is the line. So if you were to take any point on the parabola and drew a line segment from the point, the focus, to this point here, and to the line, so it's perpendicular to this orange line, the directrix, then you would see, right, you would see that those are the same distances. Now, as a conic section, what that means is that if I take a plane, slice it through the cone so that this plane is parallel to this side, the result is a parabola. Now, this is a YouTube video from a channel called Numberphile with Cliff Stoll actually making bread in a shape of a cone and cutting the bread so that you can actually see the slices. It's cute and kind of funny. Cliff Stoll's an interesting guy that I've met in the past. And yeah, should be fun to watch. I'll put the link in the description. So here's another question, and I'm going to throw in this stuff from the book so that you can kind of look at, we can talk about these things. If the equation of a parabola is written in standard form and P is positive and the directrix is a vertical line, what can we conclude about the graph? Well, the directrix then would have to be either one of the top two. So that would tell us that the parabola either opens up to the right or opens up to the left. And because P is positive, it would have to be to the right. Because notice P here this is P, and over here you'd have minus P, actually, because it moves to the other direction. I think this is here. That's why it doesn't say minus P, because this is negative. So it's going to the opposite direction. So if P is positive, that would be this one. It opens this way. Now, I think the next question will bring this up. But these are all parabolas that are set at the origin. And here in this section, they give you a set of equations to help you figure out how to calculate different things. And notice that in both of these, where they're vertical, that's x squared is equal to 4py, and the ones that are horizontal is y squared is equal to 4py. And then notice that really just all that changes is the p and the x values switch, and that's really all that's happening. This tells you how far the p is away, and this orange dotted line here is called the lattice rectum, and these are the endpoints. So it goes through the origin, or it goes through the focus, and it has endpoints on the parabola. So you can see that when it's vertical, here's P0, so you're going to go up a certain distance and down a certain distance, and that distance is 2p. So on this one, notice that the line segment is horizontal, so the y value stays the same, and this time the x value is the one that changes from plus and minus 2p. So if I go to the next slide, the question is, if the equation of the parabola is written in standard form and p is negative, so it's going to go the other way, and it's a horizontal line, the directrix is a horizontal line, then what can we conclude about the graph? Well, the horizontal line will tell us it's one of these two, and then if the p is negative, it's going to open down. Now, these are not at the origin, so we've shifted the equation for the parabola, if you look here at k and h, so we've either moved it up. Now, they have all these fancy formulas, but if you know p and you know where the endpoints of the lattice rectum are in the directrix and focus, then all you have to do is just add and subtract the right values, because you've moved it h in the x direction and k in the y value, so it's just take that last set of things and then just add the right amount. And I find that's a lot easier to do it that way than try to remember all these goofy formulas, is you just know the first ones and then know, okay, I just moved it to the right and to the left. Or up and down, depending. Alright, so these two questions kind of go together. So what is the effect on the graph of a parabola if its equations in standard form has increased values of p? As the graph of the parabola becomes wider, what happens to the distance between the focus and the directrix? Well, p is the distance from the vertex, so then these are actually kind of related. So let's look at what those do. See what happens when we mess with the distance that the focus is away from the vertex, which is also the same distance as the directrix is. So if I put a slider in here, so this is x squared equals py. So if I change the p, so if I make it bigger, the bigger the distance the focus is from the vertex, notice the flatter that the parabola gets. If I make it closer to 0, the tighter it gets, until it gets negative. Same thing, but negative when it flips around to the other side. For the following exercises, rewrite the given equation in standard form and then determine the vertex focus and the directrix of the parabola. Okay, so let's try number 16, which says x is equal to 1 over 36y squared. Now, standard form would be the y's on this side and the 36 and the x are on this side. So let's multiply the 36 across and then just flip them, right? So we get y squared is equal to 36x. That's just the symmetric property. Now, we know the vertex, because I'm not subtracting anything, is 0, 0. Now, the focus and the directrix, we need to know the p. So this thing would follow y is equal to 4px. So we know then that these two have to be equal to each other. So I take 36 equals 4p, p is equal to 9. So that would give me, now this is positive, so that means that my parabola is opening up. So my focus would be at 0, 9, and my directrix would be at, well, it's not a point, it's a, right, it's like that. Let's try that again. For the following exercises, rewrite the given equation in standard form, then determine the vertex and the focus and the directrix of the parabola. So if we try number 16, which says that x equals 1 over 36y squared. Now, standard form would have the square on this side and the x on this side. So let's multiply the 36 across. And then just switch them around using the symmetric property. Okay, so now since we're not subtracting anything from x's and y's, we know that then our vertex is 0, 0. And since we see that we have the form here 4p is x, I know then that 4p has to be equal to 36. So that means that p is equal to 9. So this is a positive value, and we know then that vertex is at 0, 0 here. The x is the linear term, so I know I'm opening up to the right because it's positive. So I get something that looks like that. So that means that my focus would be 9 units from the origin here, so it would be 9, 0, because my axis of symmetry is y is equal to 0. And then I go the other direction, and I have this vertical line, so I have x is equal to negative 9. That would be my directrix. So this is my focus, and that is my directrix. So let's do 18. 18 is y minus 2 squared is equal to 4/5 x plus 4. Now since the x is the one that's not being squared, that means that we're opening up in the x direction. Because this is positive, we know that we're opening up in the to the right, in the positive direction. So our vertex then, we can still tell by looking at this, the y would be subtract a -4, that's how we get the plus, and then the y value is just 2. So we're at 1, 2, 3, 4, 1, 2, so our vertex would be here, and we're opening up in this direction. Now, like I was saying before, all we have to do is know what the p is, and then add it and subtract it. So if I find my p value, since it's already in standard form, our 4p is equal to 4/5, and then if I divide that over, I get 1/5, right? Multiply both sides by 1/4. And now, where would my focus be? Well, it's in we're moving it in the y direction, so all I have to do is add 1/5 to -4. So if I take -4 and add 1/5 to it, that would be -20/5 plus 1/5, which is -19/5. So that would tell me that my focus has an x value of -19/5, and its y value is the same as our vertex because they're sitting on the same line. Now the directrix is going to be on this side. And again, that distance is 1/5. So now what I have to do is take my -4 and subtract 1/5 from it. So if I take -4 and subtract 1/5 from it, that'd be -20/5 minus 1/5, which is -21/5. I get the equation for a vertical line, which is x equals -21/5, and that is my directrix. Alright, so now let's do 30. This one's a little different because it's not in standard form. We have to put it in that way. So x squared plus 4x plus 8y minus 4 equals 0. Alright, so let's see, what do we want to do with this? We want to put the x's on one side. I kind of think of it as the one that's being squared. And then on the other side, let's subtract this over. So I have -8y minus 4, like that. Now I'm going to complete the square on this thing. So I take half of 4, which is 2, right? And square it, I get back to 4 again, right? So that's 2 squared, which is 4. Add that to both sides. So this side becomes x squared, x plus 2 squared. And this side just becomes -8y because those two subtract off. Oops. Catch my mistake. Sorry, it should be plus 8. Because when we subtract it over, that becomes negative. That one becomes positive. Well, let's do this again so it's not so fucked up. Alright, so let's do this one. 30 is a little different because it's not in standard form. X squared plus 4x plus 8y minus 4 equals 0. So I'm going to take everything that's not with the thing that's being squared and push it over to the other side. So I have x squared plus 4x. And I'm going to leave a little space because I'm going to have to complete the square. Subtract that over, -8y plus 4. Now I take half of this, 2, square it, and you get 4. And we're going to add 4 to both sides. So over here, I get the x plus 2 squared. Over here, I'm going to get minus y plus 8. So I'm going to just rewrite this neater. And this one, I'm going to factor out a -8. I'm going to get y minus 1. So now I know my vertex is -2, 1. I know that since I'm squaring the x, and the y is not being squared, that this thing opens up in the y direction. So I go -2 and +1, so I'm here. And then this is negative, so it's going to be opening down, like this. So it's going to be opening this way. So that means my focus I'm going to subtract from the y value, because that's this distance. And so I need to find p. So 4p is equal to -8. So my p is equal to -2. So I'm going to take, now as a distance, right, that's always positive. So the distance is just absolute value of p, which is 2. So now if I want to know how far below this is, I'm just going to subtract 2 from my y value. So 1 minus 2 is -1. So my focus is going to be same x value, and now my new y value. So it's -1, so it'll be down here somewhere. Now my directrix, I add 1 to the y, or I add 2 to the y value. So I'm going to take 1 plus 2, which is 3, and so I get my directrix, which is y is equal to 3. So that would be, here's what we have. Our vertex is at 1, 2 above it. There's our directrix, is somewhere above it like that. For the following exercises, find the equation of the parabola given the information about its graph. So number 50 says the vertex 1, 2, directrix is y equals 11/3, and the focus is 1 1/3. Alright, so if we put this on a graph to kind of get a feel for what's happening here, right? Y equals 11/3. 11/3 is what? I don't know, it's about 3 goes in that 3 times with the remainder of 2, 3 2/3. So it's up here somewhere. Vertex is, so we have a line directrix like this. We have a focus that's at 1 and a vertex that's at 1. So we can see that we have 1, 2, and focus is at 1 1/3, which is down here. So this is our focus, that's our vertex. So we can see that our parabola is opening like this. So we know that h is equal to 1. We know that k is equal to 2. What else we know? We know we're opening in the y direction, so that means that x is the squared term. And so the last thing we need is then p, right? Because we can just kind of put everything in at this point, because we know that it's going to be x minus 1 squared is equal to 4p squared y minus 2, like that. So what I need to know is, what is the p? Well, all that is the distance. There's two distances that should give us the same number. So maybe we'll check just to make sure. So that should be a p, and that should be a p. And p should be negative, I guess, so that we get a negative value because it's opening down. So we know that this is going to be negative in the end. If we figure out p as a distance, then we just positive and make sure it's negative. That's all we have to do. So what do we have? We have a y value of 2, and above it we have 11/3, and below it we have 1/3. So if I take 11/3 and minus what would be 6/3, that's 5/3. And if I take, just to double check, 2 minus 1/3, that's 6/3 minus 1/3, which is 5/3. So we can see that the distance p is 5/3. Okay, so if I plug that in, I'm going to get x minus 1 squared equals 4 negative, because it's opening down, 5/3 y minus 2. Alright, so let's just multiply it out so that just multiply the p's together, these numbers together, and we get negative 20 thirds y minus 2, and we have the equation of our... Alright, we're going to do 63, which says, a satellite dish is shaped like a paraboloid of revolution. This means that it can be formed by rotating a parabola around its axis of symmetry. The receiver is to be located at the focus. If the dish is 12 feet across at the opening and 4 feet deep at its center, where should the receiver be placed? Okay, so satellite dish with a receiver inside, right? And so what we know is that it's supposed to be 12 feet across and 4 feet deep, like that, at its center. So why don't we do it this way? Because we can graph it any way we like, so let's do it a way that feels comfortable for us. So what we're going to do is graph it like this. Here's our satellite dish. What we know is that this is 12 feet across, and we know that it's 4 feet deep. In other words, from here to here is 4 feet. So that's that one. So this would make this coordinate 6, 4. Because if it's 12 feet across, 6 of the feet is on this on one side and 6 on the other side. So that's that coordinate 6, 4 if we put the vertex at 0, 0. Now what that means is that we're going to get the equation x squared is equal to 4py. Now this is really good because the p is just the thing we have to solve for. We have an x, we have an y, so stick the 6 in for the x, put the y in for the 4, and so we get p is equal to divide the 16 over 36 divided by 16, which is, let's see, 4 goes into both of them, 9/4, which is what, 8 and 1 over 4, so that's 2 1/4, so 2.25 feet above the vertex.